Hi, Assalamualaikum. My name is Nurul Binti Azian. My metric number is 279479. With the assignment given, we will explain about the interpreting data set G, which is forest fires. We will explain about the introduction and objective, methodology, data analysis and discussion, and also the conclusion. 1.1 Introduction. Background of the study. Forest fire can be defined as an uncontrolled fire. It can occur above the height of 1.8 meter and above. One of the reasons for this fire often reaches proportions is from the burning of heat from the surface and the fire of the soil. In addition, large fire can quickly spread through the topmost spots for trees before covering forest floor growth. In this research, the data set focused on forest fire and the sample survey is conducted to get know how they reduce forest fire. 2 is objective. The objective of this research is to identify the data sets and fire weather index. The second objective is to investigate the factors and impact of the data forest fire. And the third objective is to observe the causes about the forest fire.
Now, I will present about the methodology data collection. Firstly, the types of study we have conducted through the research is descriptive statistics. Descriptive statistics are used to describe the basic features of the data in the study that have been conducted. Our research collect information and data using secondary data sources. I choose this data as secondary data because of data set for forest fire provided by our lecturer from internet sources. The method of data analyzing. For the measurement scale, we use a nominal scale for qualitative data, while interval and ratio scale are used for quantitative data. The position of Mortison Hopper. Based on table, you can see that the highest frequency of X and Y axis are 30 and 52 located at the 4th position. It indicates that the area of number 4 was the place where the forest fire event frequently happened. The mean for both axes is 16.67 and 18.75, while the standard deviation for this coordinate is 8.65 and 17.84. The median of x-axis is located at the 5th position and y-axis located in the middle of 4th and 5th position. The mode for both coordinate is 14 and 0. Quarter 1 for x and y axis are 2.5 and 2.25. The quarter 3 are 7.5 and 6.75. Based on the figure, the skewness of both coordinate data was right skewed because the mean was the most significant value.
For the data analysis result for analysis month of the year of forest fires, first, the highest frequency is 59 over 150, which is 34.6%, and the lowest frequency is only 1, which is 0.67%. The quartile 1, the 4th quartile 1 is 37, and quartile 3 is 113.25. For the analysis day of the week of forest fires is the highest frequency is Sunday, which is 21 times, each represents 18%. And the lowest frequency in analysis day of the week is Wednesday, which is 10 times, each present 6.67%. For the 5 full moisture curve of forest fires, the major frequency is 69, which is 39.33% in the class limit 91.5 until 95.4. And the lower frequency is 0 in class limit 71.5 until 75.4 and 75.5 until 79.4. The standard deviation for this FFMC is 270377422.7. As for the disaster monitoring constellation, the highest frequency at the midpoint 27.85, which is 25, and the lowest frequency at midpoint 61.85 is 3. The median of this DMC is midpoint 78.85, which is 21, and the standard deviation 7609485.46, and the histogram is skewed to the right. For draft code, the highest frequency is 66 in the class limit 657.3 until 638.2, and the lowest frequency of draft code is 1, which is class limit 171.3 until 252.2, and 333.3 until 414.2. Each represent 6.67%, and the mode for this DC is class limit 657.3 until 738.2. This histogram is skewed to the right.
This bar graph is representing the ISI index from FWI system. As we all can see, the highest frequency for this ISI index are from midpoint 11.15, which is equals to 68, while the lowest are from midpoint 32.15, 39.15, 46.15, and also 53.15, which is equals to 0. The median for this ISI index are also 0. This ogive graph is representing the temperature in Celsius degree analysis. As we all can see, the trend for this ogive graph is increasing. The highest temperature are around 150 Celsius degree, while the lowest temperature are around 1 Celsius degree. In addition, the median for this temperature are 103 Celsius degrees. Next, this bar graph is representing the relative humidity of forest fires. Based on the graph, the major frequency of relative humidity are 52, which is represent 34.67%. The lowest frequency for this relative humidity are 1.33%. The mode for this relative humidity is same as the highest frequency, which is 34.67%. Next, this ogive graph is representing the analysis of wind speed in km per hour. Based on the ogive graph, we can see that the trend for this ogive graph is increasing. The highest wind speed are 150 km per hour, while the lowest wind speed are 0 km per hour. The median for this wind speed are 132 km per hour.
The forest fire can be defined as uncontrolled fire on lands that covered by timber, grass, and other flammable vegetation. We can tell that forest fire will occur every month in a year. In this study, we can conclude that there's a various factors that can affect the forest fire, such as hot temperature, wind speed, a lack of rainfall, and relative humidity. To overcome this problem, the fire with the index FWI has been used to calculate a single value for potential frontal fire intensity, combining the rate of fire spread with the amount of fuel being consumed. Finally, the forest fire can cause the high amount of property damage, such as loss of wild habitat, lives, humans, and animals. To reduce forest fire from occurs, people need to be more alert and aware for the high-risk area.